Question 4. Function f is defined by this for this domain. Sketch the graph of f and state the range of f. Okay, so let's sketch the graph. So this is fx modulus x minus 3. Okay, let's ignore the modulus first. We draw x minus 3 first because this is easier lah. So this is actually y equals to mx plus c. So our m is 1 and our y-intercept is negative 3. So when we're drawing the graph, it will cut at negative 3 here, and the gradient is 1, positive 1. So positive means the graph will go up. So the graph will look something like this. And then you have to modulus it, right? Okay, but before we modulus, let's find the y values for the range. So they said the domain has to be between negative 1 until 7. Okay, so we find when x is 7 and negative 1, what do we get for the y? Okay, so we sub this x into the equation. So let's draw a small table. So when x is negative 1 and 7, we figure out the y. So 1 times negative 1 minus 3. You can use your calculator. We get negative 4. And then 1 times 7 minus 3 is 4. So here, this coordinate negative 1, negative 4. This coordinate is 7, 4. Okay, so this is a graph of without the modulus. Now let's change it to modulus 1x minus 3. Okay, once you get this to this stage, right, it's very easy to change. Whatever that's down here, you have to flip it up. So negative 1, negative 4 will become negative 1, 4. Okay, the graph will be like this. Alright, and then this one you can erase it. Okay, there won't be this point anymore. Alright, so this is our modulus graph. And then they asked us to state the range of f. So you need to state this range. So looks like both also ends at 4. So it's between 0 and 4. So the whole graph starts at this point and it ends at 4. Okay, for this domain lah. So the range, you can write it as f is in between 0 and 4. That's it. Okay, this is your range of f. Next, B. Find the range of values of x such that fx is less than 2. Okay, B. So when fx is less than equals to 2, so that line is somewhere here. Okay, so this will be 2. So they want us to find the range of x when our fx is less than 2. Less than means it's here. So looks like the graph starts from here and ends here for this range lah, for below 2. So we need to find these values of x, this range. So to do this, we need to do some calculation. Okay, so let's calculate what happens when fx equals to 2? So modulus of 1x minus 3 is 2. We move the modulus this side, it will become plus minus 2. Therefore, we will get two different answers. So x minus 3 is positive 2, x minus 3 is negative 2. So x is 2 plus 3, which is 5. X is negative 2 plus 3, which is 1. So when fx is 2, our x values will be 1 and 5. So this is the answer lah. Our x values ranges from 1 to 5. This is the range of x. Then, question C. On the same graph in part A, sketch the graph of 2x minus 3, hence obtain the values of this equals to that. Okay. Let's draw y equals to 2x minus 3 first. So 2x minus 3 means this is m, this is c. So our y-intercept is still negative 3 and our gradient is now 2. Okay. So just now this one, our gradient was 1. So we got that line. Now our gradient is 2. So it will be a bit steeper. So it will be somewhere here. Okay, but we cannot just assume, we cannot just simply draw. What we have to do is we draw a table and we plot the values. So when x is negative 1, we find the value of y. Then just to make sure when x is 0 and when x is 7. Okay, so this point, and this point. So let's put all these values into the equation. So 2 times negative 1 minus 3. Here we get negative 5. 2 times 0 minus 3 is negative 3. 2 times 7 minus 3, 11. So negative 1 and negative 5. So if this is negative 3, negative 5 will be somewhere here. 0, negative 3. Okay, so it cuts here. And 7, 11. 7, 11 will be somewhere here. So this is our graph. Okay. Here lah. So 11 will be somewhere here. Okay, this is 7, 11. Alright, so this is our graph. Now we need to obtain the values of x such that this equals to that. So when they say this equation or this line equals to this graph, that means they are asking us to solve the intersection point. So we need to find the coordinates of this point. Okay, so we know it will be somewhere between negative 1 and 7. Okay, so what we have to do now is we have to find out by calculation. So x minus 3 equals to 2x minus 3. So when you move the modulus over that side, we will get plus minus 2x minus 3. So this one you have to solve it separately. One is positive, one more is negative 2x plus 3. Okay. So let's make x the subject here. We bring x here and the negative 3 here. So we'll get x equals to negative 3 plus 3 is 0. One more. X minus 3 is negative 2x plus 3. Sorry, why am I writing it again? So 2x we bring there, become x plus 2x. Negative 3 we bring here, becomes 6. Therefore, x is 2. So here, it cuts at 2. So they ask us to only find the value of x, so just 2 is sufficient. If they ask you to find the coordinates, then we have to sub the x coordinate into the equation to find y. Okay, but in this case, this is enough because they just ask the x coordinate. Okay, why can't we take 0? Because it doesn't intersect at 0. So if this line were to be like this, then both the equations will intersect at x equals to 0. Okay, but in this case, it won't lah, because this part, the positive part, is already flipped. So in this case, it will just intersect at 2. So what we can do, this one we can reject. So only this is the answer.